Hello and welcome to SciJoy. Let's explore breadboards, pull-up resistors, and the Arduino IDE. Breadboards are a quick way to prototype your circuit. You can easily move components into different configurations without soldering anything in place. When circuits had vacuum tubes, they literally used breadboards to prototype. Tim and I tried to use an actual piece of bread once, but it didn't work out so well. On modern breadboards, you can see that there are these metal clips at each hole in order to electrically connect the component to different sections of the breadboard. Some breadboards have power and ground rails on the side. You should plug the positive side of your battery or the voltage out from your Arduino in the red side. This has the plus symbol on it. This means that any hole in this line will have a positive voltage when the circuit is closed. The ground should be connected to the blue or the black side. This is the negative rail. The middle of the board is typically labeled with letters across the top and numbers down the side. These rails are electrically connected horizontally with a gap in the middle, and this gap is good for chips to bridge. These numbers and letters help when mapping out your project or using someone else's design. We use Fritzing, which is a free software to map out ours. If you pick the right size board in these different software programs, you can print them out and overlay them on your board. Jumper wires are a great way to connect components without having to strip any regular wire. When you're putting components in your breadboard, you can usually bend the legs to get them to the area that you need them to reach. If you hook up something to your Arduino that doesn't continuously complete the circuit, like a switch, you should either use a pull-up or a pull-down resistor. When there's an open in the circuit, the voltage to the Arduino pin might be floating. This means that the value of the pin is somewhere between 0 and the maximum output voltage. For the digital pins, this can cause the reading to jump between high and low because it's neither 0 nor the max voltage. When a resistor is hooked to the positive voltage side, this is going to cause that pin to drive high. This is called a pull-up resistor. A resistor hooked to the ground side is called a pull-down resistor because it's going to drive the pin to low. Typically, a pull-up resistor is used, and the value for these resistors can range from 1 kiloohm to 10 kiloohms. The Arduino has an internal pull-up resistor that you can turn on using code. They're 4.7 kiloohms, but we typically just put ones in our circuit. Lastly, let's briefly explore the software that we're going to use. The hardware and the software are both called Arduino. Sometimes you'll hear it called the Arduino IDE, which stands for Integrated Development Environment. There's a link in the description to the software page where you can download this IDE. And the programs that we write in the software are called sketches. Starting with the buttons at the top, you can verify that your code doesn't have any errors in it with this check mark. And if you do have some errors, they're going to be listed down below. You can upload your program to the hardware portion of the Arduino by using this right arrow. Then you have your typical new, open, and save buttons. This magnifying glass is pretty important. It's called a serial monitor, and you can send and receive real-time values using this monitor. And we're going to use this a lot in the future. The actual program is brought to you in 3 parts. Before any of the predefined text, you can define items and open libraries. There's only so much storage space on the Arduino hardware, so you don't want to put all the libraries in there at once. It's kind of like having a backpack, and you only want to carry the books that you're going to need. As they state, the void setup is for things that you will only do once and at the very start of your program, and never again. Like you might say, hey Arduino, these are the pins I'm using. If you recall from our robotics series, things inside of loops happen over and over and over again until we tell them to stop. The same thing happens in this sketch. Everything inside this void loop section will happen over and over again like a checklist on infinite repeat. Arduinos aren't great at doing things in parallel, so it's just going to go down and check things off the list. When you're hooking up your Arduino for the first time, you need to pick the type that you have, and this is under Tools and Board. If you're having problems communicating with your Arduino, you probably need to change the port that you're using. This is also under the Tools menu. If you go to the File menu and Examples, they give you a bunch of pre-written sketches that you can use. Many of them have links that will take you to web pages that have further explanations and resources for setting up your circuit. If you make changes to these sketches, be sure to save them as a new file. Thanks so much for watching. If you have any questions or comments, let us know down below or on any of these social media platforms. You can support us at patreon.com/SciJoy, and remember, keep exploring.